Oops. This is the old equilibrium. Here was 30, here 60. And now we have our costs higher by 15. So what we do? Higher by 15 by this tax. Agree? So new equilibrium, new marginal cost equals to marginal revenue. We will sell 25 right now, and then we need to find how much our consumers will pay. Put into demand. This is their maximum willingness to pay. Yes, 65 they will pay, but they will pay 65, and then after they pay 65, our monopolist should give 15 to government, and in profit there will be no this not 65 from each unit, but 55. And this will be minus 15 somewhere here. 50. This is the price for buyer. This is the price for seller. And the difference is the tax. This is the definition of price of buyer and price of seller. How much seller will get. Or we can show, then we can show profit, new consumer surplus, yes, and new tax revenue and deadweight losses here. Let's see. New consumer surplus will be the area under inverse demand function and above the price that consumers will pay. They will pay 65. Yes, this is new consumer surplus. New producer surplus, you can show this is about your question right now. You can show that new producer surplus is 65, the area between 65 and new marginal costs, and you will be right. Yes, this trapeze, because our marginal costs are higher. Yes, this trapeze, this will be a new profit of our monopolist. Or you can show the same profit as the area under the price for seller 50 and old marginal costs, because the technology did not change. You see, I will show like this and like this. This area equals to this area. They are equal, and we can you say that we counted everything in marginal costs to then to find the profit as in my graph as green trapeze. This will be from your point of view the profit, and I explain about the red area. The same. It's the same. Okay.
Okay. Thank you.
I hope that it's better. Why I explain through red area here? Because it is easier to show tax revenue on the graph, and that's all. So, producer surplus. So monopolist will have 50 from each unit sold, and above marginal cost. This will be producer surplus. And where is tax revenue? You see, yes? Tax revenue of the government is tax multiplied by quantity that will be sold. Yes? This rectangle is tax revenue. Do you see it?
Mm-hmm.
Mm-hmm. And now we see that we have higher deadweight losses, bigger deadweight losses than before. So this was deadweight losses from monopolization of the market before. And now we have more deadweight losses from taxation also. Good. This big black triangle is deadweight loss from monopolization plus taxation plus government intervention. Deadweight losses.
Karina Anatolyevna, can I ask you to explain the deadweight loss once again, please?
So, two parts of deadweight loss, or what is it, deadweight loss?
What is it and how it works on this graph particularly, please?
Oh, okay. Deadweight loss is the loss of social welfare of society. The best, the maximal social welfare we know, it's the situation of perfect competition without government intervention. When we cross demand and marginal cost, yes, this will be a perfectly competitive market. This will be quantity in perfectly competitive market. This will be price in perfectly competitive market. So this is consumer surplus in perfectly competitive market. This is producer surplus. All this, consumer surplus plus producer surplus, the sum of surpluses of all economic agents that are present in the market, this is the social welfare. We call it like this. Social welfare. And it is maximal. You do not see here losses, yes, maximal. And then when we have government intervention or monopoly or all other markets or other situations, we always compare social welfare in the market with best maximal social welfare. And the difference between this big triangle and the sum of surpluses of economic agents that we have now is the loss of society. How much society loses.
Okay,
And
thank
that's
you.
all. You see, compare this big triangle, this one, with social welfare right now. Social welfare right now in monopoly plus taxation is consumer surplus plus producer surplus plus the revenue of the government, because government is also an economic agent, yes? So this trapeze, and compare it with this triangle. The difference is the loss of society. The difference between maximal social welfare and that we have now.
Understood. Thank you.
Can we finally prove that both of the sides are wrong in their predictions of the taxation, or we should prove it in a geometrical way, count the social welfare and compare it, and so on? It is right now we can understand it from the graph because we see in geometrical way that the DWL is much bigger and all of the actors are losing in this.
You see, let's read carefully statements. So first statement, the equilibrium price increased by fraction of the tax. This is true or false?
This is true.
This is true, yes, this is true.
Okay.
Because before we had the price 60 and now we have 65. So price increased by 5 and this is 1/3 of the tax, yes? Tax is 15, price increased by 5 for consumers, yes? Let's explain it. So equilibrium price increased by 5 and explains 65 minus 60, yes? So by 1/3 of the tax equals to 15. Good. So first statement is true. Fraction of tax. This is true. And the second statement, let's see. monopoly will pay smaller share of tax. What we know about buyers? Buyers pay how much? 1/3 of tax. They pay by 5 more. Yes, they pay 1/3 of tax, and monopolist will pay how much of tax?
Zero. But because they include it in the price.
But they have 50 after they pay the tax.
Oh, okay. They'll
not
pay
pay,
10,
but,
10.
term. Yes, 10 over 15 is 2/3. Easy.
Yes,
Yes.
yes.
If consumers pay 1/3 of tax, yes, then producer, monopolist pay 2/3 of tax. Yes.
Mhm.
Because,
Okay.
and 2/3 is a bigger share of tax, not smaller. So this statement is false.
Mhm.
Agree? Let's write down and prove it. So this is false. Why? So consumers will pay, let's name it T of buyers. And this is the difference between what they pay now and what they paid before over the tax. And this is 5 over 15, 1/3. You can calculate how much monopolist will pay. Monopolist will pay, this is the share for monopolist, for seller. The difference between what he had before and what he has now. Seller over the tax. And this is 10 over 15, or 2/3. Or you can count it 1 minus 1/3, because all tax is 1. Yes.
So
It's the,
it's gonna be monopoly pays bigger share.
Monopoly pays bigger share. That's why this statement is false. Monopolist monopolist pays bigger share. That's why this statement is false. Yes. So, по-русски вот эти штуки, которые считаются, они называются налоговое бремя. То есть в каких долях, да, распределяется налоговое бремя между покупателями и, ну, в данном случае, продавцом одним. Вот. Да, по-английски это называется share of the tax, но мне больше нравится налоговое бремя, потому что это как-то очень красиво звучит, да, потому что, ну, как бы налог это, в принципе, обременительно. И вот кому больше, там, на кого больше, да, накладывается вот это бремя налога. Вот, это можно вот так считать. Да, там, какую долю налога платят в итоге покупатели и в итоге продавцы.
Если вот у нас будет подобная задачка на экзамене, нам как оформить ответ? Вот примерно просто вот в наших вычислениях написать true, false, или нужно будет как-то это выделить?
Нет,
Какой
ну, вы смотрите, что мы здесь сделали? Мы посчитали, сравнили, написали, что платят больше, и пишем, следовательно, statement false. Ну, то есть, вот,
ну, вот так вот примерно, как вот и тут.
Да.
Всё.
Да, ну нормально, вот такими, знаете, вот стрелочками, да, там следовательно, как бы к выводу приходить.
Можно еще
Вот.
такой вопрос? Мы написали, что, если я не ошибаюсь, получается, buyers платят 1/3, то есть 5, и там же просто не было этого в задании, может быть, я что-то упустила. Почему мы решили именно, что они платят 5? Или это так всегда, что они платят 1/3?
Нет, это что такое 5? Да, это просто разница между тем, сколько они платили раньше и сколько они платят сейчас. Сейчас они платят 65, у них в магазине цена, а раньше 60 была цена до введения налога. Ну, значит, рост цены для них составил 5. Правильно? А это 1/3 от налога. А налог на
Оттуда мы уже
15.
вычисляем, то есть все остальное, кроме 5, платит уже монополия.
Ну да, вот раньше монополист себе в карман клал с каждой единицы проданной продукции 60, да, а теперь он кладет себе в карман сколько? 50. Значит, 10, вот это 10 как бы с него идет. Вот. Да, это 10/15, ну, 2/3 от налога. Ну, Я думаю, понятно. Так, пожалуйста, еще вопросы?
Я хотела уточнить еще, вот когда мы были на dead weight loss, вообще есть такая в монополии ситуация, когда dead weight loss отсутствует?
Ну вот сейчас в пункте D такой будет.
Хорошо, спасибо.
Давайте посмотрим. Окей. Point D. И еще даже без государственного вмешательства, если у нас первый тип дискриминации, то там тоже не будет ДВЛ. Но вы, по-моему, дискриминацию не проходите, поэтому ладно. Point D. The government changes its policy. It cancels the tax and considers introducing a price ceiling to make monopolies output more affordable to the poorer customers. At what level should the price ceiling be set to maximize social welfare? So what is price ceiling? Who knows?
Потолок цен.
It's the maximal price higher than which we cannot set. That's the price, maximal price. And we should find such maximal price such that social welfare will be maximized. But we know when it will be so. I said it today for 3 times or something like that. When we have the situation when social welfare is maximized.
When there is the equilibrium price and
No, where it is the perfect competitive market without government intervention.
When we have a perfectly competitive situation. So our government should set such maximal price which can be as in perfect competition. Yes. So this marginal cost, this is the demand, marginal revenue. And when we have perfect competition, we cross demand and marginal cost. Yes. Let's cross it. Social welfare is maximal when perfect competition. When perfect competition, inverse demand should be equal to marginal costs. Let's find 90 minus Q equals to marginal cost Q. From here, quantity that will be sold if we have a perfectly competitive market is how much? 45. Yes, yes. And price is also 45. No, star here, 0. So here 45, here 45. And
So, our price zone is 45, right?
Why is it so? Let's see. Without this price ceiling, our monopolist will set 60. You remember, yes? Higher price, 60. Yes, and sell how much? We've got 20, 30, yes, 30. But now, if we set the price 45, and this will be price ceiling, maximal price, we say to monopolist, you cannot set the price higher than 45. So he cannot set 60, yes? He will set maximal affordable, 45, yes? This will be new equilibrium price. But for this price 45, it's not profitable for him to sell 30, yes? He will sell more for such low price. He will set 45. He will sell. This will be new equilibrium quantity. And new profit of our monopolist will be the area under the price, 45, and above marginal costs. This one, this is producer surplus, new producer surplus. Consumers now, after such government intervention, after such price ceiling, consumers, they will pay less than before. They will pay 45 instead of 60, and they will buy instead of 30 more, 45. So consumers are better off. The area under inverse demand function and above the price that they will pay is new consumer surplus. And you see, this is exactly the maximal social welfare, yes, with such government intervention. Good.
Yeah.
Thank you.
Mhm. So, okay. Then. Okay, guys, let's do from the next class, class 9, let's do number 2. In class 9, we should speak about game theory, about sequential games and simultaneous games. Number 2 is about simultaneous game. Let's see. Mhm. So, interactions of the seller and the buyer are summarized in the payoff matrix below. The seller decides on the quality of the product she is selling, and the buyer decides whether to buy a product or not. The decisions are made simultaneously. So we have simultaneous game. What that means? They decide on optimal strategy independently and simultaneously. Independent of each other. Now, here we have 2 players, seller and buyer. Seller, first player, has 2 strategies to offer good product or bad product. 2 strategies. Second player, buyer, has also 2 strategies to buy the product or not. And in this payoff matrix, we write down the payoffs when they will play these strategies independently and simultaneously. What payoffs they will have? Let's write down. Here we'll have seller. The payoff of the first player will always write in the first place. The seller will have 2, buyer will have 5. Then here -3, 0. Here 4, -5. Here -1, 0. Point A. Does the seller have a dominant strategy? Who wants to explain? Anastasia? No?
Yes. The seller will have the dominant strategy if he will decide to offer the bad good product, because in both cases he will have the biggest number. So for example, if the buyer will buy, if the seller will offer bad, the number is bigger, 4 is bigger than 2. And if the buyer doesn't decide to buy, then again the seller's number is bigger, because -1 is bigger than -3. So it will be the dominant strategy of the seller.
Thank you. So let's explain one more time. Thank you. So what means dominant strategy? Dominant strategy, if this is the station, if you choose the strategy, no matter what your opponent does, yes? If it is profitable for you to play the same strategy, no matter what second player does. So let's see. If buyer will want to buy, so seller will play bad quality because he will have payoff, not number, but payoff 4 instead of 2. Yes, 4 is bigger than 2, so he will choose bad. Put here dash. Then, if buyer will not buy, it is not profitable for him to make good quality. He will make bad quality. Why? Because -1 is bigger than -3. In the table, 2 dashes in one row, that means, okay, all dashes in one row, that means dominant strategy. Yes? So dominant strategy is bad, and we explain it. Why is it so? Okay. Then, what about buyer? Who wants? Artur, maybe.
Okay, here we have the situation of the if he wants not to buy any product, I think he'll also be in the dominant place because, or if it wants to buy the good product, because how to say it? If the sellers decide to sell a good product, the
We want what? Buy or not? If seller will choose good,
we will buy, of
we
course.
will buy. So put here 5. You see, payoff of buyer is on the second place. Then, if seller choose bad, what we will do?
We will not buy
We
it.
will not buy because 0 is bigger than -5.
-5, yeah.
So what conclusion we make about dominant strategy of buyer?
It is not. It is good, or I don't know how to say it, because we
Who can answer? Valeria, maybe. What about dominant
Um,
strategy?
It is gonna be good as we have 5 bigger than 0. If we're comparing buy good and not buy good. And no,
No, buyer does not have dominant strategy here because his decision to buy or not to buy depends on the decision of seller. You see,
okay, yeah.
That's not a mistake.
but it's strange because we have simultaneous game.
Yes, simultaneous game. So one more time. Never. We now are speaking about buyer. Do not tell that good is the strategy of buyer. It's not the strategy of buyer. It's the strategy of seller. Okay. And now we speak about buyer. What means to have dominant strategy? To play the same strategy no matter what your opponent does. Here, buyer will buy if seller will sell good product, and not buy if seller will sell bad product. So the decision of buyer depends on the decision of sellers. That's why buyer does not have dominant strategy. Does not have dominant strategy. One more time. Why seller has dominant strategy? Because he will sell bad product no matter what buyer will do. 2 dashes in 1 row. And buyer will choose different columns. Yes? Different columns. That's why he has no dominant strategy. We can explain as if good, then buy. Explain 5 greater than 0, and if bad, then not. And explain because 0 bigger than -5. So the decision of buyer depends on the decision of seller. These are decisions of seller. And in our table, what is the equilibrium situation? What will be in the equilibrium? Who knows?
Bad and not buy. No, Nash
Yes.
equilibrium.
Yes, this is the Nash equilibrium. You see?
Yeah, it's gonna be -1 and 0. Yeah.
-1 and 0. These are payoffs, equilibrium payoffs. And equilibrium is the set of optimal strategies. Optimal strategies here, Nash equilibrium, optimal strategies for seller. On the first place, we write down the optimal strategy of the first player, so of seller to play bad, and the optimal strategy of buyer not to buy. payoffs, equilibrium payoffs. -1, 0, but it's not Nash equilibrium. It's typical mistake to write in the answer. Your task is to find Nash equilibrium, and you write in the answer -1, 0. It's mistake. You will get 0 points. Yes.
Okay. So
This is the answer if you are asked to find Nash equilibrium.
okay.
Okay, a set of optimal strategies.
So buyer will like always depend on seller, right?
The strategy of buyer, we wrote down it.
And he depends on
Because,
seller, right?
yes, it depends on seller choice. And in equilibrium, they will, what is the Nash equilibrium? The Nash equilibrium is the situation when no one wants to deviate. Yes? Only in this situation, when seller plays bet and buyer plays not, they do not want to change their strategy. They do not want to switch, to change the strategy. So we say that this is Nash equilibrium situation. In the table, it's easy to see that here are 2 dashes in one. Okay, then is it the best situation? Do we have Pareto improvement in this game? Is this Pareto efficient situation? Who wants?
Maybe not, because buyer sellers lose.
Because
And,
we can improve it.
How?
Buyer can buy a good and seller can offer good product.
So this situation is not Pareto efficient because we can make Pareto improvement. Remember the first class number 1 for micro course. Yes, we have Pareto improvement. Now they have payoffs -1 and 0, and we can make them better off, them both better off. To give to seller 2 and to buyer 5. They will be better off both. So this situation is Pareto improvement for our Nash equilibrium situation. So let's write down. So this is not Pareto efficient situation, as we have Pareto improvement. It's Pareto improvement. And Pareto improvement is to play good and buy. And explain why this is Pareto improvement. Because in this situation, seller will have 2 instead of -1, 2 greater than -1. So seller better off. And for buyer, 5 bigger than 0. That means buyer better off. But as you see, this Pareto efficient case is not equilibrium case. They will never be in this place. They will never be. They will change their strategy. Let's see why they will. Why this is not equilibrium situation. So if the seller will play good, buyer will do what? Will buy. Okay. But if buyer will buy, what seller will do? He will not make good quality. He will make bad quality because for him it is more profitable, you see? So seller will deviate from good to bad if buyer will buy. That means that they will never be in this situation, in this equilibrium situation. Yes, they will deviate, they will change the strategy. And the only equilibrium situation is to produce bad quality product and not buy it. That happens. And our conclusion for this point is that Nash equilibrium and Pareto efficiency, they can coincide, but they not often coincide. Yes. So if we find Nash equilibrium, it will never, it will not always be a Pareto efficient case. Okay.
Yeah, okay.
Okay, so let's see what are Pareto efficient outcomes of this game. Mhm. Do we have another Pareto efficient outcomes of this game? We see this outcome bad and not, we have Pareto improvement. Goodbye. And for example, if this -3 and 0 is Pareto efficient outcome, do we have from this situation Pareto improvement? From -3, 0.
No,
Why no?
because
Yes.
it decreases. No.
Where we need to move? Here, yes?
Yes.
Seller will be better off and the buyer will
Will be the
be
same.
same. But it's also Pareto improvement. So this situation -3, 0 is not Pareto efficient because we have Pareto improvement. Then 4 -5. Do we have Pareto improvement from this situation?
No.
No.
No Pareto improvements. Yes, because for seller it's the best 4. Yes, and if we will move to other place, seller will be worse off, and this is not Pareto improvement case. Yes, so this 4 -5 is also Pareto efficient situation because by definition Pareto efficient, that means no Pareto improvements. That's all. How to write down it? Let's see. But by okay. So 2 Pareto efficient situations. Goodbye and bad bye. Why they are Pareto efficient situations? Because we have no Pareto improvements. Because no Pareto improvements. Pareto improvement, no Pareto improvements. That means that we cannot make somebody better off without making somebody worse off. That's all. That means we are in efficient situation. Guys, please questions about this task.
No.
Okay, so we will stop here.